Hello, Data. We are almost done with this trimester. I have no idea how many days are left, but we are getting there, and you are hanging in there. Hopefully, we won't do anything too hard for you. Quadratics, old school, that's what we're doing today. And all that's different between yesterday and today is I'm going to see set equal to 0. It's the only difference, which changes things a little bit. But then we're going to use a lot of Desmos today, and I'll show you some really cool stuff. So when we factor this, let's refresh our factoring rules. This x squared is made by x and x. This negative right here tells me that I should have one of each. And the factors of 3 are just simply 3 and 1. So I know I need a negative 2 here, so this is going to be minus 3 plus 1. Okay? Now I've got the plus or equals 0 there. And there's this property called the multiplicative property of 0. Right now, you can pause the video and try saying it. Multiplicative property of 0. It's quite fun to say. It's almost like trigonometric. Well, it's just fun math words to say. So multiplicative. Go ahead, pause the video, try it. It's a good time. We're going to set both of these equal to 0. So x plus 1 equals 0. X minus 3 equals 0. We're going to solve those. X equals negative 1. X equals 3. Now, you're probably like, well, I've seen this before, Mr. Manor, and I don't know what that means. Well, let me show you what that means. That means that on a graph, okay, if I wanted to graph this, this shape is going to be a parabola. Okay, any quadratic or trinomial is a parabola. And it actually crosses the x-axis at negative 1, 3. So if I go to an x value of negative 1, put a dot, and 3, put a dot, that's where it's going to cross the x-axis. So those two are x-axis crosses. You could write them if you wanted to as negative 1 comma 0, that one, and 3 comma 0. And that would tell me which points they are. Now, this parabola is going to open up because it's a positive x squared. It's going to just go down through this point. It's going to come back up. It's going to go through this other point here, okay? So why are those points important? Because they tell where the parabola crosses the x-axis. I know you're thinking, still not important to me, Mr. Manor. I know, but there's some really cool problems that we'll do here that maybe you'll think they're a little bit interesting. If this happened to be a negative in the front, that means the parabola is going to go upside down, and that's what we're going to talk about today, is what happens when the parabola is upside down. But let's graph this one right now. So I'm going to click over to Desmos. We're going to graph that problem. So it looks like this. You just go to Desmos calculator and go X, and then you hit the caret, which is shift 6, and it takes you to the power. So X and then caret 6, X squared, minus 2X minus 3. And you'll see it graphing along the way. And to minimize, maximize, you just use your trackpad to scroll in and out. Check this out. The x-intercept is negative 1 and 3. So I know you're thinking now, well, I don't need to factor, and that's actually quite accurate. You don't need to know how to factor unless you're taking like a college algebra class, and they're going to make you factor by hand, which is legit. There are things, some problem-solving skills factoring by hand. Some other things that are important, this is the bottom, net 1, negative 4, the minimum, and there's a y-intercept of 0, negative 3. And this tells you everything, by the way, that 0, negative 3 comes from right here. Okay, so if you put your formula or your equation into Desmos, it will actually give you the parabola that it's working with. Let's see if we put a negative in front, what happens? Ah, yes, turns it right upside down. So let's see if we can find that thing and look at it. So flip the parabola upside down. If I take the negative out, actually you could add another one if you wanted to. So I could add x squared. So it goes shift 6 squared, and let's do minus 2x minus 3, the exact same parabola, and except for a negative there. And you can see how they're a little bit different than each other. But one opens up, one opens down, and that's how you graph parabolas on Desmos. So let's go back here, and let's say I told you a story. All right, my story is, let's say Ty C, I don't know who that is on the HHS roof. Okay, Ty, do not do this. All right, when you're watching this, do not do this. He's on the HHS roof. He has in his hand a baseball, and he throws it up with a velocity of, let's go 15 feet per second. And I know that sounds a little bit weird, not miles per hour, but we're going to stay with 15 feet per second now. All right. He's got a radar gun and he changes it over to 15 feet per second. He throws it up in the air. So it goes flying up in the air and then it comes sailing down and lands on the ground. Now, where he's standing on Homestead, all right, so he's standing on the HHS roof. The HHS roof happens to be 40, let's go 30 feet high at that point, all right? So here's Ty, okay, and he reaches and he throws a ball up. It's going to come down and land on the ground way down there. All right, whoops, can't see. All right, so here's Ty. We're going to neglect Ty's height right now because it makes the problem a little bit easier. So here he is on top of Homestead on the edge. Careful, Ty, don't fall off the edge. Don't do this. Don't do this. Throws the ball up 15 feet per second and down it comes. And we said Homestead is 30 feet high at that point. Okay. Now here's the cool part. This is actually a parabola. You don't see the other half. That parabola has an equation, and here is the equation for that parabola. When you're dealing with feet per second, it's always negative 16 x squared. That negative 16 is what we will use all day today. The reason why it's always the same is because gravity pulls down on that ball, neglecting wind resistance, at the same speed every single time. Negative 16. Plus is the miles per hour at which he throws the ball up, 15x. And lastly, the next one is the height of the building that he is on, or the height at which it's thrown upward. And now we have an equation for the scenario. All right, so let's graph it and see what Ty looks like on Desmos. Graphing this negative 16, negative 16x squared, right? Plus his initial throw upward. So he reaches down, he throws it up really hard, 15 feet per second. And he's standing on a 30-foot building. And we're wondering when that ball is going to hit the ground. So here is the scenario. I'll zoom in a little bit, a little too far. All right, so here's Ty standing right up here. Up he goes, ball goes, and then down it starts falling down, and here it comes, it's going to hit. All right, so there it is. It's going to hit that axis right there. And as you could see from before, when you have a parabola, the points at which it hits the axis right there are the x-intercepts, and you factor it. Now, I'm not going to ask you to factor this because Desmos does it for you, right? So on Desmos, my question is, when does it hit the ground, right? So I'm going to go over here and let's ask that. When does ball hit the ground? Okay, we're going to use Desmos. And you'll be using Desmos to do this today. All right, so we'll use Desmos. So we got this picture over here, and all we need to do is click on the equation right there, and it tells us that this point right here is 1.916, comma 0. So let me tell you a little bit about those numbers and what they mean. The 1.916 is how long it took the ball to hit the ground. So just under 2 seconds, that ball is going to hit the ground. The 0 means that's the height. So what's the height of the ball when it hits the ground? 0. Let's do a couple other checks. And by the way, this part of the parabola doesn't really mean anything because the ball started up here on the top of Homestead. Let's see. If I click up here, it'll give me the maximum. The maximum point is, let's see if I go by it. So at 0.469 seconds, the ball is 33.516 feet high. So that first number is the time. The second number is how high the ball is. So Ty, you threw that ball an amazing 3 feet up in the air, because if you started at 30 and you ended up at 33.516, excellent job, Ty. Amazing throw. All right, so my question for you is, when does the ball hit the ground? Let's take a peek again. And the answer is right there, 1.916. When does the ball hit the ground? 1.916. 1.916 seconds. Right. I might ask you another question. What is the maximum height? Okay, what's the maximum height? Let's go check and see if we can see that what that is. We did that once already, the maximum height. So right here, I said to click on it. Boom. It tells me 33.56. So at 0.469 seconds, it traveled to 33.516 feet. Okay. So you're going to get two questions that I'm going to ask, or you're going to be asking. You'll see you're going to end up making some story problems. When does the ball hit the ground, or when does the object hit the ground? What is the maximum height? So you're going to click on the top to get the maximum height. Click down here to get the when it hits the ground. Now, just so you know, this is the actual path of the ball. The ball isn't being thrown outward. This would be just a vertical up and down. But you don't have to worry too much about that. This is just for looking at things and practicing. Let's try one more of those. Okay. So let's go with somebody by the name of, let's go with Zoe. Okay. Zoe is stuck in a tree. All right. Zoe's stuck in a tree and she climbed up there. All right. And so we'll say at 80 feet. All right. So she's stuck in a tree at 80 feet and drops her phone. So she cannot call anybody for help. So it's not a good situation, but it's a happy story in the end. Somebody sees her, calls the fire trucks. They come and they rescue her. All right, so it's all good. So she's stuck at 80 feet and she drops her phone. Okay, without hitting any branches or no wind resistance. When does it hit ground? All right, when does it hit the ground? What is the maximum height that this phone goes? Okay, so when does it hit the ground? What's the maximum height? Let's write our equation. Looks like this, and I normally go y equals for my equations. That's fine. Negative 16 x squared, and then plus. Now, this is the initial upward throw. Does Zoe throw the ball up at all? She does not, so it's 0 miles per hour. She's just dropping it. And then plus 80 feet because she was 80 feet in the air. Okay, so that's my equation. And let's go and see what Desmos tells us. So let's jump over to Desmos. Negative 16 plus 0x, and I really don't have to put 0x, but I will, plus 80. All right, so here's Zoe, way up here. Poor Zoe climbed to the top of a tree, can't get out, and she dropped her cell phone. Notice that the ball does not go up, or the phone, I'm sorry, does not go up. It's because she accidentally dropped it, right? So it's just going to come down. So actually the maximum height question, this one, is just simply 80 feet because it's not going to go any higher if she just dropped it. That's an easy one, right? But we need to know when does it hit the ground. So all we got to do is go over here, scroll, 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 come on down to the graph, scroll, scroll, scroll down here and click on it and it'll tell you at 2.236 seconds. So if it didn't hit any branches or whatever, hit the ground at 2.236 seconds. Remember, the left number is how long it took. The right number is how high it went. Okay, so if I go up here, Zoe dropped her phone. There should be no time when she dropped her phone. So it should be 0 on the left and it went 80 feet high because that's as high as it went. For your assignment, you're going to be making up some story problems. Just read in the Google Classroom. Should be set. You have an awesome day. See you later, Data. Bye.